Welcome to Going Beyond Math. This is a look at palindromes. Palindromes are really cool things that exist in our world, and they can fit in lots of different ways. Sometimes we see them in words. Sometimes you can actually see them in sentences. Sometimes you can find them in numbers. So on the screen you see a couple examples of some word palindromes. Palindromes are words or numbers that can be read forwards and backwards, and they're going to be the exact same thing. So dad is D-A-D, backwards it's D-A-D. Just like mom is M-O-M, M-O-M. And madam is M-A-D-A-M, M-A-D-A-M. And some people have a lot of fun with these, thinking of ways to work with words and work with numbers in this way. In fact, there's actually a place in Boston that is famous for the man that wrote this very, very long poem that is all palindromes. And he had a record for that for a very, very long time. We are going beyond math though. And with going beyond math, we're going to look at how numbers fit into this idea. And when it comes to numbers, almost every number can be turned into a palindrome. So not every number actually fits this. There's actually the number 169 has not been proven as a palindrome. They've actually had supercomputers going through it and cannot find a palindrome for this using the technique that we're about to go through. So that's why we say almost every number, not every number. But when it comes to turning any number into a palindrome, there's a very simple process. You're going to start with a number like 1,296. Step 2 is you are going to reverse the number and add it. So you see how I flipped it around. The 6 became here, the 9 went here, the 2 went here, the 1 went here. And by adding those two numbers together, I get a 7, a 1, carry the 1, a 2, carry the 1, and an 8. And I'm going to pull this over. And you can see that I got the number 8,217. And you can double check my math if you don't agree with me, but I'm pretty sure it's correct. Now that number in and of itself is not a palindrome. And so we need to continue working with this to make sure that we get an actual number that is a palindrome. And so once again, I add the reverse. And by adding the reverse, right, 8 plus 7, 5 goes down, 1 goes up, 1 plus 2 plus the 1 carried. I'm doing a lot of mental math here. So if you can't follow me, don't be afraid to write this on your paper and double check my work, all right? This is the answer you would get though if you followed through with all of it. You'd get the answer 15,345. And once again, you might say, well, that's not a palindrome either. That's a 1, that's a 5, that's not reading it the same way. But this process, as I said, keeps working in the exact same way. And so if I add the reverse, once again, I'm going to get, here's the reverse. And in the end, I get this for an answer. And suddenly I have a palindrome, 69696. And if I read it backwards, 69696. So 69,696. And so I took the number 1,296 and I turned it into the palindrome 69,696. Kind of a neat little process that you're able to do. What you are going to be doing, your challenge for this next week as you work through this problem is you are going to have a list of numbers from 1 to 99 and you're going to find the palindrome for each of those numbers. And so what you're going to be doing is you're going to be working through this process. You're going to have a starting number. You're going to reverse it and add it and continue doing these steps until you come up with a palindrome. Now for the most part, it takes anywhere from 1 step to usually about 6 steps, though there will be a couple numbers that I give you that actually have more steps than that. But I'll tell you about that in class. So this is palindromes. Hopefully it all makes sense, and we'll talk about it quickly in class before you get started on this challenge. That's going beyond math.